I'm going to show a little video of how to use one of the Tessellation Dynamo examples, and we have a built-in file that we can open up to use for it, but I'm going to do a new one just to sort of show you how you can apply it to anything. I'm going to open up a mass template, and I'm just going to give myself some starter geometry to work from. And again, you can open up the sample file that comes with it, but just to show you that it can be placed on other things. I'm going to make just a little shell kind of piece of geometry here. And this is, again, just using regular Vasari or Revit functionality, not anything special to Dynamo. So I'm just making myself a little form. And I'm going to fire up Dynamo. And I'm going to open up in the help menu, I'm going to open up samples, tessellation. I'm going to go with just the regular tessellation example. And when this opens up, it takes a little bit. I'm just going to minimize this over here because I'm not going to add any more nodes right now. I'm just going to use what we've got. So what this sample does is it's going to take a surface, a face that's selected out of the canvas over here, and it's going to create a bunch of UV points on it, and it's going to make a pattern on those surfaces using something called a Dynamo tessellation patterning, and I'll show you what that does in a second. But let me just hook this up and we can sort of see the result, and then we can talk about it. Or I'll tell you about it because this is a video and it's not a dialogue. So there. I'm going to select a face. Bam. And so now I've got my face selected. It says face ID. So this has now been piped into my definition. Right now I'm not actually running this. I just opened it up and you can see that run automatically is not checked. I'm going to check that and run it. And you don't really see anything happen right away. But if I go over here into my Watch 3D, I can right click and zoom to fit, and you'll see a couple of things happening here. One, this surface that I picked is being re-represented here, and then the tessellation is actually being represented here as well. You're not seeing anything out here in the Revit canvas because right now what I'm dealing with are elements that are not Revit elements. It's just pure geometry. And I'll show you how to instantiate Revit geometry in a second. So a couple of controls here that I can do. So I've got the Watch 3D so I can look at what's going on in here. And I'm actually just going to full screen this just so we can get a little more screen real estate and look at what's going on. I can also represent what's going on here by going to View and Enable Preview Geometry. And if I right click out here, I'm going to zoom to fit. And so now I can actually get something in the background. So I don't even have to use this if I don't want to. We're working on some UI for this, but right now if you press Escape and then use your middle mouse, you can move around that preview geometry and zoom in and out of it with your middle mouse. Again, when you're holding down Escape, you can do that. Right click gives you an orbit with that. And if you want, you can also turn off various aspects of these things so that they don't show up. So say I just want to be looking at my tessellation, which is a little bit obscured right now. If I right click on my select face, I can say display output, but don't display output. So now I'm just showing the geometry that I want to see. So there we go. And so now I've got this sort of quickly regenerating geometry. So if I move my slider, what this is doing is it's feeding a randomized UV coordinate generator that is in turn feeding off of the face that I selected. And you can see it'll very quickly regenerate different views of that same kind of geometry because I'm not making Revit elements. Revit elements take a little while to generate, so I'm going to stay in here in this sort of abstracted geometry state for a little while just to explore this surface. The other thing I can show you is I have a UV grid that's a regular UV grid, just dividing up by something that's a little bit more standard, and then I've got my random grid. So I can actually take my tessellation and I can pipe in a different grid to it. And now with the regular grid, I get actually a regular distribution. And you can also explore exactly what the Dynamo tessellation is doing if I start exposing what these UVs are. So right now these are not, this is sort of, you can actually see what this information is that's coming out of these UV grids. If I put in a watch, you'll see that I can get a list of what exactly is coming out of here. And it's just two coordinate points, a U and a V, that describe a point on the surface of that, that domain of that face. What I can also do is I can make XYZs out of those. So if I do, let's see, I think it's evaluate. So if I do evaluate UV, that'll allow me to actually create XYZ coordinates from those UVs. So let's say I want to pipe in the UVs that are coming from here and that face. Now we can see those points being represented. So what do these lines have to do with these points? Well, the way that a Delaunay tessellation works is that, this is kind of cool. It's also kind of, basic hello world for computational design. What it does is it derives the midpoint between every one of these points and then creates a perpendicular line that extends until it intersects with another perpendicular line generated from another 2 points. Now, what that means for a regular distribution of points on a grid is that you get a regular grid. If you take that out and let's look at our random distribution of points, and we pipe our random distribution of points back into the Delaunay tessellation, you can see the same thing happening over here. So I've got 2 points, I've got the midpoint between them, and then a perpendicular line extending until it intersects with another extending perpendicular line. So this is all sort of well-traveled territory for computational stuff. What's kind of exciting about this is that we don't have that in Revit for the most part. So now I've got the ability to get this sort of patterning happening in this environment, but I don't have any representation of it yet in my Revit environment. So this is where it comes into actually making real Revit elements. So now I've got a curve by points by line, which is a node that actually creates real Revit geometry. So if you can feed it a geometry line, it'll spit out a curve by points, which is a Revit element. So if I take my output from my Delaunay tessellation and I plug it into my curve, you can see over here, ta-da, I've got regular Revit geometry. And this is, first-class Revit geometry. That is, it's stuff that, will behave like any other Revit geometry. I'm just going to hide this for a second so I can take a look at what I've made over here. So these are real lines, these are real points, and I can do stuff like I can host other points on them. I could host families on them. I can place families through this as well. So the other thing is that these Revit elements over here are not really static. They're still connected up to the rest of this definition. So if I move my slider, I'm going to get reactions over here in the Revit geometry. And so one of the things I just want to illustrate here is that there is a difference between working in real Revit geometry and working in this sort of abstracted geometry, because the abstracted geometry is really quite zippy. Revit geometry, there's a lot of other things that go along with it. There's properties and metadata that go along with Revit elements. So depending on how you want to work, you might stay longer in the unrevitized geometry for longer. The other thing is that you can still do this sort of stuff where you're plugging your regular grid into it, and you still maintain this same list of points and lines. It's not recreating these, it's just reorganizing the existing set of lines. So that's all for now. There's another tutorial I'd like to do about showing how you can attach these sorts of lines and points and have them drive family geometry rather than just lines and points. But that will be for another time. Thanks for watching.